This is a nice little conceptual question, so let's read through it together. Consider a car at rest. We can conclude that the downward force of the gravitational pull of Earth on the car and the upward contact force of the Earth on it are equal and opposite because the two forces form an interaction pair, the net force on the car is zero, or neither of the above. Well, whenever I see whenever I'm seeing problems that deal with forces, we have two different forces, I'm going to draw a free body diagram. So I look at this, and I look at the force downward. The gravity pulls the car towards the Earth. We call this the weight force. Points downward. It's the interaction between the Earth and car. Car has mass, the Earth has mass. The two masses get drawn towards each other, or the Earth pulls the car towards it. It's the best way to explain it at this point. But it's the interaction between the car and the Earth. Well, there's a second equation. Assuming we have our nice little car here, we know that if this car were just to feel the weight force of this, then it would just keep falling. There would be one force. That force would provide a downward acceleration because of Newton's second law. If we have a net force, if we have one force, we have to have a net force. If we have one force, then we have to have an acceleration. However, we don't have just one force. We have an upward force from the ground pushing up on the car. So the ground pushes up on the car and causes the car to not fall through. Well, we know that this car does not accelerate. The acceleration in this value is zero. So because the acceleration has to be zero in here, the net force that was applied on this car, the net force that would cause this zero acceleration, that net force has to be a zero as well. So the forces add up to zero because these two forces are equal and opposite, not because they're interaction pairs, but because they have to add up to zero to provide us with a zero acceleration, which is what this situation is. It's kind of an interesting thing, is that the normal force will kind of react to the other forces around it. So if we push on the top of this car and we add another maybe downward force, just by pushing up on the top of this, then that normal force will grow larger to counter it. I mean, there's a point where the ground will start to break and will start to, cause a big hole in the ground. But under normal circumstances, the normal force will be providing an upward force that counters this and provides the acceleration equaling 0k. So the net force equaling 0, which gives us an acceleration of 0.